And all right, here we go. Hey, good morning, everybody. Today is your first lesson in science. Our first unit that we're covering is called the scientific method. The scientific method is a process that scientists use to actually solve and answer all questions. Now, when we talk about this in science, a lot of people think, ooh, scientific method, all we can do is talk about science. That's not true. The scientific method is actually a process that you can use to answer any question. And it gives you good results and data so that if somebody asks you why or what makes you say that, you have answers for them. You have proof. You have evidence. And in the science world, you have to understand, I got to have proof. I got to have evidence. You can't just say, oh, this is what happened. You got to tell me what's going on. So we're going to start by covering the scientific method. The learning target for today is by the end of this class, you should be able to tell me what the 6 steps in the scientific method are. So that's what we're working on today. We're going to walk through a little bit. What I want to do is show you how I use the scientific method in an everyday problem in my life that took me through to an answer that got me the best results. So I'm going to jump over here to a slideshow that you guys can watch. You should be able to hear me as we do this. So here's what we got. We have the scientific method. This is your intro video. So in talking about this, I had a question in my life. And that question was, when I started working here in Mason City, I live in St. Ansgar. So I live right here. And I work right here. So the question really come down to, and that's what the scientific method starts with. It starts with a question. The first thing I did was thought about, and I know you guys are thinking it too, what's the fastest way to work? I didn't want the shortest way. I wanted the fastest way, because the fastest way to me is when I don't have to spend a lot of time in my car. So in all reality, there is a couple different routes I could take. Now, I could go from St. Ansgar, right here, and I could go down to Highway 9. I could drive from here over to Plymouth up to 12th Street, and then 12th Street into John Adams Middle School. That's route number 1. That's the red route. The blue route I could have taken, and I can go the same distance. I can go from St. Ansgar to Highway 9, but in this time, I'm going to turn on the Norris Springs blacktop, and I'm going to cut through Rock Falls, and then I'm going to come down, over, and down. All right? That's the blue route, and then my last route is the green route. And the green route takes me straight down. We're going to follow the same path again. But instead of going here, we're going to turn. But this time we're going all the way to Norris Springs. We're going to take Norris Springs all the way over, and we're going to get to Mason City. So that was my question. Which route is the fastest way to go? Now, working at this, the second step in the scientific method then is do observations or research. Well, observations, research, what's the first obvious thing you should do if you're going to find out how long or how far or how fast a trip takes? Right. Most of us go to Google and we look up the distances. So the distance on the blue route, turned out to be 37 miles. The red route turns out to be 35 miles. And the distance on the green route is actually about 40 miles. It takes a little bit of a difference between the two. All right. Now, I've done my research. The next step I have to do is step 3, and that is make a hypothesis. A hypothesis is an if-then statement that tells me what my prediction is and why. So I'm looking at my data here, and if it's 35 miles, my prediction is if I drive the red route, then that will have the fastest time. That's a well-written hypothesis. All right, your next step, of course, once you do a hypothesis, we need to actually do this. which means we need to design a test that's fair. And the best way to find a test that's fair is that we have to keep some things the same. Those things we keep the same are called constraints. So we need to think about those things that we want to keep the same. For instance, I need to drive the same car. Why? Because one car may accelerate more than the other. I need to drive the same speed limit. I need to leave at the same time during the day and start my timing from there. I need to make sure everything I can is the same. All right? So I did this. And every day I drove this, and I did 1 week on each route because it's not fair to do one trial. And here's why. If I flip a penny and it comes up heads, if I only flip it once, does that mean it always comes up heads? And we know that's not true. We have to flip it many, many, many times. So I drove this for a week. And here's what my data showed. That when I drove the red route, it took 49 minutes to drive the red route. The blue route took 39 minutes. And the green route took 51 minutes. That's my data. That is the fifth step in the scientific method, is to collect data. So I ran my data, and these are my averages. Now, my conclusion then is, my hypothesis is false because the red route is not the fastest, the blue route is the fastest. And that's the last step, draw a conclusion, step 6. So as we go through this, I want you to think, by the way, what happens that would have made the blue route faster by 10 minutes than the other two routes. And the key here is there is a object that runs through everything right here. And people are like, oh, a river. It's not a river. It's a train. And the tracks go across the road in Plymouth, the tracks go across the road in Norris Springs, but in Rock Falls, there is a bridge that goes underneath the tracks. And so you don't get stopped by the train. So it's always faster. Okay, that was a short demonstration of the scientific method. So here's what I got. We're gonna skip these. We don't need to do those. But here's the 6 steps. Step number 1 of the scientific method, by the way, that is a way to ask and answer questions. And these slides will show up on your first test. So step 1, ask a question. It's a question that is why, what, who, where, how. You've been through all that. All types of questions are questions that can be answered with the scientific method. So the first step, ask a question. Second step, make observations, do research. This is an important step because here's where you find out what other people have learned and know. Observations are done using your 5 senses. And we'll talk about those, I think, tomorrow, what the 5 senses are and how they apply to what we're doing. Step 3 is form a hypothesis. We will spend some time on how to write a good hypothesis because a lot of your lab assignments, one of the big points is, did you write it correctly? And always remember, it's written as an if-then statement. If I do something, then this should be what happens. That's how we're writing this. Step 4 of the scientific method is design an experiment. Designing an experiment allows us to actually test the hypothesis. Designing the experiment is a step-by-step process on what you're going to do to prove or disprove what you think is going to happen. Step 5 is going to be analyze the data, which means you collect a data table. Here's where you prove it. I always demand proof, and the only way to have proof is to have data, which means you have to put stuff in a spreadsheet, a table, a logbook. You have to go through this and record this to help us analyze what's going on. And then last but not least, step 6 is draw a conclusion. In this step, we basically restate our question and tell people whether our experiment was true or false. Not right or wrong, true or false. We'll spend some time covering each one of these things. Over the next 5 days, we're going to focus, or 6 days, we're going to focus on each one of these steps and hopefully have a little activity that goes with each one so that you guys can see what's going on. Make sure you check the homework section and turn in anything that needs to be turned in so that we have these taken care of. And we'll see you tomorrow. Oh, by the way, before I see you tomorrow, remember controls. Controls are the things that we keep the same to make the test fair. We'll talk about controls a little bit more tomorrow as well. All right, you guys have a great day. Got any questions? Don't be afraid to ask.